Well, good evening. Excited to be here this evening. And I'm Lucinda Andriani. I serve as Deputy County Manager and the Flood Control District Administrator. We have, I think, this team has really worked hard and really pushed hard. And I think we have what I think is a pretty darn good plan to share with you tonight about where we're going. Many of you we've had conversations with. I know Chris has been out and I think pretty much met with everyone that we need an easement from. But we certainly want to share it for everyone in the corridor. And but I'm excited about this. I think we have the opportunity to deliver an important service and impact into your neighborhood. And I think we've already got somewhere about a half a dozen easements signed. So we're working through that process, and there's a lot of complexity to all this, as you guys know, but everything's starting to come together, and I'm excited about moving this forward. The goal here, of course, we can't guarantee no future loss, but you've sustained a lot of loss. A lot of you lost homes during the fire and then the flooding, and I've had a lot of loss, and I want to acknowledge that, and that's our goal, is to reduce the level of loss you're going to experience in the future. And, to that end, I put in this quote here from Chief Seattle, mostly to emphasize the last piece there. All things are connected. One, the integrated system that we're engineering and want to deliver, and then that we are all connected, meaning everybody in the corridor has to work together if this is really going to happen. So that's really to emphasize that. Tonight, I'm going to kind of kick it off with a status update and a little bit of history for anyone that might be new in the area. And then Alan and Chris, respectively, on and off Forest, will go through the plans. Then Corey Helton with Jay Fuller will review the no adverse impact analysis, which a teaser, it looks beautiful. And he'll walk through that with you. And then we'll talk about next steps. So as we go along, I think it's usually good if we can complete a section and then you ask questions, but it's okay to, at the end of that section, if you want to raise your hand, if you got a question. If it's a specific question to your property, I'd prefer that we do that afterward in the back. You'll get, when they have the plans in front of them, I think you're going to get a lot better answer. But if it's a more general question, then certainly let us know, inject. So, you want me to take the clicker? Sure. Thanks, Sean. Okay, so all of you are pretty familiar with this, unless you're new to the area, in terms of the Schultz fire and the efforts that were done there. And there was, this area declined the post-wildfire mitigation, but obviously we've all moved on from that. That's history. We're moving forward. A lot of effort going in to deliver you a really great system. 22, these are the stats. You've seen these before. We've ultimately spent a little over $9 million all told largely last year. Very little this year. We had some of you we probably should have put the video in. Did we put the video? We didn't put the video in, darn. It would be great for you to see the video. Let's make sure we send out an email with the link. So some of you may be aware, because you did get a little bit of impact into your area. On July 30th, we had about a 3-inch rainfall event in an hour, primarily in the Brandis and Wupaki Trails areas. And as you know, Wupaki Trails in particular was really hard hit the prior year. And they're much like your watershed. It had completely unraveled. And literally on that Tuesday, Tiffany completed construction of their storm drain system, the storm drain underground pipe, like what's proposed for your area. And that Sunday we had that major event, and we also had upsized the existing channel that was there, and the system worked beautifully. It was unbelievable. There wasn't a single, we didn't have to even get out a shovel. Like you said, it was pretty amazing. I was out there with people, and people were literally crying because they had watched the gauges and seen what was happening, and to see the water contained in the channel, contained in the storm drain was pretty amazing. And that house, well, this is government tank. I was going to say that's not Chase's house. It's in government or in Mupaki, but there were no impacts. So, and that really goes back again to a lot to that on forest measures. Like the level of debris that came down was about 20 feet. Everything was small, nothing clogged. It was just amazing how effective all of that was. So that's what we're working on for your area. So you'll recall seeing this graph before. We've seen this significant increase since the pipeline fire in terms of flood flows. You're all very aware of that. You've lived it. Again, want to emphasize this integrated system of the on-forest watershed restoration coupled with the neighborhood flood mitigation. If we don't do both, we can't move forward. We have to do both. If there's nothing else we didn't learn from going through this now twice, is that integrated system is fundamental to success. And frankly, I'm watching them in New Mexico try to do some stuff downstream, and they're saying, well, we get one rainfall event and everything fills up with sediment. Well, yeah, you are. That is what's going to happen if you don't do something on the watershed. So important to emphasize that. You'll hear more from Chris about the actual designs, but we're targeting this 2-inch and 45-minute, basically a 25-year storm rainfall event. As everyone knows, we have to meet those no adverse impact standards, again, that Corey will go over. And that we can't mitigate all impacts. There will still be bigger events that exceed that capacity, but I'll tell you, we can't really measure the positive impact of the on-forest measures. So getting those done is really critical to all of this, because Chris will be the first one to say, if I can put a pipe in, but if it fills up with sediment, it's not going to deliver any benefit, right? Our budget is limited, and we're scraping pennies, and we're doing the best we can to live within the budget. We have a set budget for the 4 northerly corridors, and we've expended the part we had expected to expend within Upaki and Brandis, and now we've got a pretty big expenditure coming, obviously, for Peaceful and Copeland. And again, key to all this, you're going to hear this over and over again, the more quickly, Mike's ready to go to work. Mike, stand up, raise your hand. Mike Garrison with Tiffany Construction, they were phenomenal. He's ready to go to work. And as soon as we get those signed, he will begin working. He'll begin relocating utilities. They're doing the on-forest. They were the successful contractor that was awarded we call it construction manager at risk contract. That's by state law. Anything over $2 million has to go to through a competitive process. They did, selected based on qualifications. And so they will be constructing both the on and off forest measures in your corridor, and they're just the best. I mean, they'll work with you. They're really good. As I think many of you know, they did almost the vast majority of the work post Schultz as well, and they've gotten just particularly the on forest they're amazingly efficient. Here's where we are. So we're at 60% design. So what you're going to see in terms of plans tonight is the 60% designs and the no adverse impact at 60%. There will be some level of, I'll say, mostly like tinkering and things with the plans from this point going forward, but probably not major changes, particularly if we're going to stay on track. We've got to be able to move through. But this is the point at which we start to secure the easements, and both Nikki and Shanique are in the back with Tierra Right-of-Way Services. They're working on our behalf to secure your signatures on those drainage easement documents. And please, if they call, respond. Please set up a time. They're going to come and meet with you. If you have questions, get with Chris and or Rick tonight, and Nick that's in the back. If you have questions, please get with them tonight. Get the questions resolved. Hopefully you can get those answers, concerns you have. Let's get them resolved so we can get those easements signed. We are, some of you may be in up off of Glodia. We are integrating in a measure to address the flooding that's occurred south of East Copeland that comes down through that drainage. There's that smaller watershed there. Some of the flow comes from Copeland, some comes from that smaller watershed, but we are, and Chris will go through that tonight. He will address that, but to help some level of that flooding as well. So that's incorporated into this. We've received the NEPA clearance, the environmental clearance from the NRCS. So on that front, we're all good to go. There were no archaeological sites identified in the area. So we're all set from that end. We're all set for construction. There will be a monitor on site whenever they're digging, and but we're all set to go. They have initiated, you've probably seen Alan Adams out there. They're doing potholing now for the utilities to determine the depth of the utilities and accurate locations. And Mike's been working very closely with Donny Park Water and the other utilities on that front. We frankly don't expect a lot of impact there because, as Chris will tell you, we're going pretty deep. So I mentioned about Tierra. Again, we need those easements as soon as possible. And, you know, we're making another element of investment that we're going to need to make to effectuate this corridor is that the basins at the western side of the Copeland detention facility, those have to be upsized to be able to accommodate. If you think about the water coming through that system, it's going to get there more rapidly, so we have to accommodate those impacts so we aren't impacting the highway. ADOT doesn't want to accept mitigating their impacts, but we have to mitigate the impacts to the highway. So I'm working on that. We've applied for a grant to cover that cost. Unfortunately, the review of that grant, those applications has been delayed, so we're going to start a major effort back in DC to try to get that reviewed sooner than later. We had expected it to be reviewed in October, and now they're saying it'll be December, early January. It's like, well, no, that's not acceptable. We need to know now, because that's a pretty major investment. And that's a grant through Department of Transportation. So with that, I'm going to turn it over to Alan. Anything on those kind of general pieces? Any questions for me before I move on related to that? Yeah, Ruthie. Shanique, do you have an overall number? Does anybody remember the overall number of easements that we need on both corridors? That's what I was going to say, 35 to 40, somewhere in that ballpark. And so they've gotten about a half a dozen. So they only started, what, week and a half ago? So So they're, they'll move through it. So. No, they should come, but they're here tonight. So anybody that wants to sign tonight, they'll be happy to take your signature. and they're here tonight if you want to set up an appointment with them. So I know Nikki's coming up several times a week to do that. They're both coming up. So set up. Well, you should have talked to them. Have them look at your document because it depends if you have a trust or not, right? So they'll advise you. So, but work with them to set up an appointment. Because I know she's got a set of appointments set up for this weekend, next week, but she can do more. So again, I need to get him on the ground. We really want to start construction, if preferably before snow flies. So. All right, anything else? Good question, thank you. Any other questions, comments? All right, thank you everybody for hanging in there with us. I really appreciate everybody's been, good with communicating and hanging in there with us, and I really appreciate that. I appreciate the partnership, so. All right. Alan.
Thanks. Good evening, everybody. Can you guys hear me fine? Does this not work? How about if I just talk really loud? Will that work?
Yeah, we need it for the.
It shows its green. I don't.
Let's get it, Rosa. Because we tape it, because some people, can't come.
How's this sound? Can you hear me now? Okay, great. Thank you. Thanks. Good evening. I just want to talk a little bit about what we're doing on the hill above the neighborhood, on forest work, the watershed restoration, and then we'll get into the real meat of the matter down through the neighborhood where Chris is. But first of all, a little bit about the current conditions, or what the current conditions were just a month ago. For those of you that have lived here a long time, you were here during the Schultz fire, and after the Schultz fire and that flooding, you had flooding, but it wasn't the alluvial fans and the channels in your watershed held together, and that was a great thing. And we didn't really have to do much work up there, and things recovered quite nicely. That is definitely not the case today. So the alluvial fan systems that you see up here used to be pretty much an even field all the way across here. And this is what they look like now. It's a little bit of like a Where's Waldo, because there's an actual full-scale human standing in that ditch right there. Totally. That's 5 foot right there. So these are tremendous big gouges in the alluvial fans. They channelize water, and they concentrate the shear stress that was spread across those alluvial fans, and they are responsible for kind of delivering the high volumes of water as well as the high volumes of sediment downstream. So that's kind of what the things look like in the watershed now if you haven't walked up there. And it's a completely different story than what it was after the Schultz fire. After the Schultz fire, it looked a little ratty, but things were geomorphically, they were working. Now, not so much. So the whole process of this watershed restoration is to restore those alluvial fans and restore channels where that's appropriate. But and restore those alluvial fans, we can really cut down on the sediment transport. And that's really important because way up high on the steep portions of the hill, you've seen those big gouges. Well, those are deep as well, 6 and 8 and 10 feet deep. And those are going to start delivering sediment for decades to come. And we need a place to put that sediment besides down in the neighborhood. So rebuilding these alluvial fans is the secret. And this is this is kind of what it looks like. This is an old and destroyed alluvial fan after the museum fire a couple of years ago on the other side of town. And this is what it looks like when it's restored. And you can see here we've got a 6 to 8 foot deep channel, about 8 foot wide, that really concentrates flow and starts bringing all of this debris out with it. Once we restore that back, we can spread flows out really wide, keep them really shallow. And this is a pretty significant rainstorm, and we're not getting very much sediment at all. And it really slows the water down. So that's kind of what we're trying to achieve. And that's what it looks like after the museum fire. This is kind of what it looks like as we go, as the practices go. This is the Tiffany crew right here rebuilding that very same alluvial fan from and it takes large machinery to do that, and a lot of really competent guys. You're fortunate to have them. We're putting in grade control and building these terminal trenches. This is at Brandis, rebuilding that after the pipeline fire, replacing all of the log structures that were there. And this is what our grade control looks like. We're using really, really large rocks. And we design those so that they don't get moved in the biggest flows that we can think of. And this is a crossvein weir. We use these for channels. This is a buried rock sill that we use for grade control on alluvial fans. Big and wide, buried in the ground so that head cuts cannot move up through it. And these have worked really good. Those of you that were here during Schultz, you heard us talk about log sills in the fans. They worked great until they burned up, and then they don't work. So we're going with rock now. A little bit more expensive to do, but it's going to be a more long-term fix. So also in the North Copeland drainage, we're going to be we plan to install a plug-and spread fan. And plug-and spread is a little different way of building that same alluvial fan wide area for flows to spread out. We've had some good success with this on the Schultz Creek side. We can build these fans, we can build a great area fan without doing a lot of work. So it means we don't have to take out all the trees. We can work around archaeological sites and miss those kind of things and still be able to spread the flows out. And that's what this looks like over in Schultz Creek. This is the plug in the middle of a channel, okay, and this is what it looks like all along the side. So water comes in from the top right here, hits the plug, and has to spread out into the wide valley on either side of it, creating that spreading, shallowing, and dropping out of sediment. And we've already seen this work pretty good on the Schultz Creek side at moderate flows already this year. So we're excited that this is a new way we can do stuff and kind of work around the live trees that are still up there. So of course, all of this requires reseeding with native seeds, as we've done in the past, and also utilizing all the trees that have to be removed, grinding them up and putting that down as mulch so that we can have a weed-free mulch up there to give us a good start back into the biotic succession once we get the water to do what we need it to do. So a little bit about what's the specific plans, and we have, so Duke MacArthur from our office and Mike Curley have really burned the midnight oil and the morning oil and the midday oil and all of that to kind of get to this point. We're not quite done, so we're still refining things, as Lucinda said, but we're pretty darn close. And we're just going to walk you through what it looks like on Forest. We have some more detailed plans in the back if you're interested and have time to stop in. We'd love to talk to you. But so this is what we're calling the high fan up here. Here are you guys down here, main Copeland drainage, the North Copeland drainage up here, Copeland Avenue down here. So this, and then the 420 road runs right along here, so you know where you are. This is the high fan. this is, that's about 40 acres. That is the largest alluvial fan by twice of anything that we've built in around the San Francisco peaks since Schultz. It is currently almost finished. We got a couple weeks to go. The Tiffany crew has been up there. You might have noticed some big dust clouds up there and a bunch of, yeah, you can see it from the moon actually. But this is going to do a lot to arrest a lot of the sediment coming off of here. It's not going to do very much to arrest water, and the water's going to come down and keep going and trying to pick up sediment from these lower portions. But when we get down into working below the 420 road, we need to make sure that we know where that water's going and it has a place to go. And that's why we can't really get a whole lot closer to the neighborhood without getting a place for it to go through the neighborhood. So this work is going to help, but right now it's really going to help the 420 road a lot more than it helps you guys. And so that's what we're doing. This is what that 40-acre fan looks like. It's about 1,500, 1,600 feet long. It's really big, and but still pretty steep. So you can see it carries. We're hitting 8% grades, so it's still going to be able to carry some pretty significant sediment across it, but probably stopping about 80% of it that gets there, which is still a big number. So the lower fan and terminal trench. This is, here's the, wait a second. Hey, come back. Go the other way. You would think after 10 years I'd learn how to use this thing. Okay. Yeah, so the upper Copeland fan, and then that is a lower terminal fan and trench, which is not right, is labeled wrong. Sorry about that. That's the upper fan. The plug-in spread on North Copeland, this is what that looks like right through here. These are those plugs going across the channel, spreads it out. We've got a little bit of a berm over here to make sure it doesn't spread too wide. And we catch it in a terminal trench, and then it goes through a hardened channel down to the neighborhood. I don't think all those slides got in there. I think there's more in the... Yeah, they're in there. Sorry about that. We will walk over that. Please come back and take a look, and Duke and I can walk you through it. But when we get down to back you up a little bit. So this right here, this is their middle fan. It extends all the way across the 420 road. Again, it's just a big wide fan. We incorporate the 420 road into it. And then it comes down across this area and is spreading out like it normally would, okay? We have an area right in here where it's going to split out and go to North Copeland, and then most of it keeps going down to the main Copeland drainage. This thing that you see right here is a regulator, and it's basically a giant rock weir built into this incised channel that will only allow 300 CFS to continue down here, because that's what the condition of this pipe down here will be, and Chris will talk about that. Anything that is that gets split this way in excess of that 300 CFS comes back across and joins this big fan all the way through here, and then down here right above the pipeline, we start expanding that fan out and rebuilding the old fan surface, which served us for so long. There's a little pit right in here for a borrow, comes on down here, and then finally we have a terminal trench to catch all of those flows right here and feed them into a transition channel which meets the pipe right about here. Now flows in excess of what the pipe can handle spread back across and out of the terminal trench back where they went before. And Corey can talk more about that. But these are, this system captures and handles an awful lot of sediment and a great majority of the flows. So
the other thing to really emphasize is that, you know, the flows, the 300, and then what was the southern flow, Corey? 1600. Mm-hmm. That has been what's come to be through the modeling, right? What you all saw last summer, you know, toward the end of the flood area. So what we're doing with these is we're not changing where the water's going, but we're making sure that it continues to go there in the future. And that's really critical to all this. We're going to put millions and millions of dollars into this system. And you don't want the water to decide to migrate north 10 or 20 feet, right? Or south, right? It's got to get to that inlet. And so, or, you know, even if we were using a channel, same thing, it wouldn't matter. But we've got to be able, that's one of the key benefits of doing the work on the forest is much more predictability about where's the water going to go and making sure it goes where it's gone before, because we are going to have events larger than the design storm, the 25 years. So that's really important. You'll see that in his modeling. But anyway, just wanted to make sure that was clear to people. So we're not just pushing the water to the south.
Okay, so I'm going to pass it on to Chris unless somebody has something general about the on-forest work. Please come back and talk to Duke and I. We feel kind of lonely back there if you don't come talk to us. All right, so.
All right, well, thank you. I'm Chris Duza with Civil Tech Engineering. I know a lot of us, if not all of us, have already met out on your properties. So good evening, it's nice to see you all again. So I'm with Civil Tech Engineering, and we're part of, you know, a three-pronged team, well, more than three prongs, but the engineering team being a three-pronged team, being Civil Tech that's working in the neighborhood improvements, Alan that's working up on the forest improvements, and then Corey with J.E. Fuller that's doing the no adverse impacts modeling to make sure that everything that we're designing, everything that we're planning, again, is not going to have adverse impacts moving forward. So a little bit of history. I know Lucinda already touched on this, but these Copeland watersheds did burn back in the Schultz fire. They mostly burned, but they didn't entirely burn. When the pipeline fire occurred, this watershed did burn entirely, including the steeper slopes in the upper part of the watershed. What's been modeled by Corey in the post-pipeline fire condition, various storm events, but what we're targeting for these improvements is that 2-inch and 45-minute storm event. Statistically, you know, based on our most current data, that's about a 25-year event or a 4% chance of happening in any given year. But it seems like it's almost like an annual event with a summer monsoon. But statistically, you know, based on the current NOAA Atlas, it's about a 25-year event. So you'll hear us talk about the North Copeland Corridor and the South Copeland Corridor. So that South Copeland Corridor, the one, you know, with the big fans that Alan was talking about, is the larger watershed, and for that 2 inches and 45-minute storm event, it delivers about 1,600 CFS, or cubic feet per second, at the boundary between the forest and the neighborhood. So I know for us, you know, CFS means something, but for you, you know, a cubic foot, 1 foot by 1 foot by 1 foot, 1,600 of those going by you in 1 second. That's a lot of water. So what's the base flow of the Colorado River? 10,000 at least. I mean, yeah. So this is a lot of water that we're talking about. For the North Copeland Corridor, It receives, it's a smaller watershed, not as much flow there. We're talking about 430 cubic feet per second. And when we met previously, I believe it was in June or July, there's another watershed that sits just to the south of the Copeland watershed that we call the Glodia watershed. And again, that was burned by the fire. It's where those 6 culverts are underneath Copeland. And the people that live on the south side of Copeland were getting some pretty significant flooding there as well. And so what we discussed at the previous meeting was, hey, is there any way that we can get some relief, as part of this overall project? So that's something that we looked at, and I think we have a pretty good solution for that as well. So that watershed delivers about 200 CFS there, and as part of this overall project, we're going to provide some mitigation for that as well. So a little bit about what I was talking about. We have a pointer on this, Ellen? Okay, we do. So this is what I'm calling the South Copeland watershed, and you can see these numbers here are those discharges, about 60 CFS, about 1550 here, and they come into the neighborhood. This is the forest boundary. They come into the neighborhood here. This is that Glodia watershed where we see about 200 CFS that comes through the lots here. That set of 6 culverts that we were talking about is right about here. And then you can see the different colors on the map represent different flow depths that occur across the land as a result of these storms. The darker colors, the purples, the oranges, the yellows, are deeper flow depths. The lighter colors, with the lighter blue and the darker blue, are lesser flow depths. And then, of course, you see these basins, the existing Copeland basins, you see those filling up with water. So again, here's our 200 CFS coming in. Here's our about 1,600 CFS coming in. And you can see where where the canyon has kind of formed through here. And then once we get to about here, it really spreads out in the lower part. As you guys are all aware of, it looks like we have another alluvial fan starting to form down through the neighborhood. And then this is the North Copeland corridor, where we have this 90 CFS that's coming and this 337, and further up here, we're able to pick up about both of those. And then this is where it enters the neighborhood, and you can kind of see the flow path that it comes here. And then things really start to fall apart here, where the flows kind of diverge in all different directions right now. Okay? Okay, so the plan is 2 different separate conveyances through the Copeland corridor, the North Copeland and the South Copeland. South Copeland being that 1,600, North Copeland being, the 430. And we're going to pick up that other 200 in Glodia and get that over to the South Copeland improvements. For the North Copeland improvements, we can convey that flow in a 72-inch diameter or 6-foot diameter storm drain pipe. So from the forest boundary down to the Copeland basins, and these pipes will empty down in the Copeland basins, we're talking about 4,500 linear feet of pipe on both of these corridors. So we're looking to put about 9,000 linear feet of pipe in the ground in a couple of months. which is going to be a monumental effort on Mike's behalf back there. So the South Copeland corridor, a much larger pipe, a 10-foot diameter pipe is what we're going to need to convey those flows through there. 120-inch, 10-foot diameter pipe, and then another 72-inch diameter pipe that's going to pick up that flow on the Glodia watershed and deliver it to that 10-foot pipe. Okay? So what's key in all of this, Lucinda had mentioned, are the easements. There is no mechanism for us to construct and maintain this system through the neighborhood. That's why we need the drainage easements. So the drainage easements are, dedicated to the county flood control district across the private property. We were hoping to be able to get the 120-inch, the 10-foot diameter pipe and a 20-foot easement. Mike can't do it. We get so deep in some places with that pipe that physically he's not going to be able to construct that in that small of an easement. So we're going to have to go a little bit bigger, but we can still go with a 20-foot easement on the 6-footer. Okay.
Deep legally, you have to shore the sides of the, there's some areas they're going to have to do shoring and everything. So you got to fan it out enough that he can meet the safety requirements, right?
Mike, can you speak to that real briefly about what this construction is going to look like?
Okay, folks, can you hear me? Okay, to give you
Pull it up a little bit higher, Mike.
okay, to give you a brief idea of the size of the pipe, you think the top of that rim is 10 feet tall. That's how tall this pipe's going to be. The upper ledge of that screen is going to be the top of my trench coming through your property. So you start running that out wide. I'm about 17 foot to the outside of my shore boxes. I'm running a machine that comes in at 118,000 pounds. For every stick of pipe, it's 32 dump truck loads of dirt for every joint of pipe that we put into this hole that comes up and out of it. And that's in the best perfect soil conditions. What's happening, you folks have, some of you got rocky yards and some of you got some real nice farm dirt. That farm dirt doesn't stand up. So my ditch now that is 17, 18 feet wide starts turning into 24 and 25 feet wide as it starts working its way out. So it does take a considerable amount of room. Once you start seeing this pipe show up, and again, that's the height of the pipe. You're inside the ditch right now, and that's what you're looking at. So to give you any idea, once this coming through, it's going to be a sight to see, and it'll be something that you've never seen. It'll definitely be something you won't forget, but it does take a little bit of room. But what you can be guaranteed with is when you deal with us, you will be taken care of. We take great pride in what we do. We understand that it's your yard, that it's your home, that this is your livelihood. We're there to really take care of you. This is what way we do this. We got to get our pipe in the ground, but we always treat it as if it was our place. How would we want it to be handled? How would we want to be treated? And that's what you'll get from us. But it does take quite a bit of room.
All right, thank you, Mike. I appreciate that input. So the picture below is actually, I believe that's the 6-foot diameter storm drain pipe that a section of it that we just installed out in Wapaki. So that gives you a little bit of scale as to the magnitude of that pipe, and then you see a utility line going across the trench there. And as Lucinda mentioned, right now we're in the process of potholing or figuring out exactly where all the utilities are at, so that we can avoid most of them. For the most case, we're going to try to go underneath them. Okay. Some considerations for the design, even though Alan guarantees me there's never going to be any sediment or debris ever coming out of the forest again, we'll still plan for it. So, all that work that occurs on the forest, it has several benefits in that it does significantly reduce the amount of sediment and the debris. Those alluvial fans spread the water out, so it's not as deep, it's not traveling in an incised channel, it's shallower, it's moving at a slower velocity, it allows debris and sediment to fall out. So that's the key, that's what I'm counting on for the work on the forest. But we still need to be, we expect some sediment and some debris still to make it down, and we want to be able to transport as much of that as we possibly can through our system in the neighborhood, which ultimately minimizes the maintenance. We've talked a lot about fences. A lot of you, I know there's fences on the property line, and in general, not in all cases, but in general, we're trying to put the pipeline alignment along property lines. That doesn't occur everywhere, but in general, well, typically there's fences on those property lines. Our plan is not to fence off both sides of the drainage easement, but just to put the fence back on the property line. And, ultimately when this is all said and done, hopefully life goes back to normal and your property looks like it did before, with your fence lines and those sorts of things. So those fencing costs are non-eligible costs, which means our federal funding partners don't pay for any of that. That comes out of the district's coffers. So we try to be, a little cognizant of that as well. I know trees are an issue on a lot of properties. You know, people have, they have beautiful trees on their properties that they want to try to save or maintain, and we are doing our best to minimize the impacts to trees. In some cases, you know, we're going to lose some trees. It's just that it's just going to happen. But we'll work with you on, you know, replacing trees. You know, obviously we can't replace a 35-foot tall, you know, ponderosa pine with another one. But, you know, we're working with the residents, everyone on that. Roadway elevations and driveway elevations, we're not going to be modifying those. We will be crossing roadways and driveways, but we're going to put them back to the same elevations that they were previously. Again, I mentioned utility relocations. Again, these are non-eligible costs for our federal funding partners. So when we're moving water lines, gas lines, electric lines, when we're moving all of this stuff, that comes out of the district's coffers, which is why we're trying so hard to avoid utility relocations and put those dollars into the improvements that we're making and not moving utilities around. You know, one thing that we've been working on recently, you know, Mike mentioned we're going to have a lot of dirt. You know, we're going to put these pipes in the ground. We're going to have a lot of dirt. So instead of trying to haul it away to the landfill, there's quite a bit of cost associated with that. You know, we have these very deeply incised channels that are cutting through your properties. So what we'd like to do, and what we're working on developing on the plans, is filling in those channels, not entirely, but, you know, some of these things are canyons. You know, they're 20 feet wide and, you know, 20 feet deep. But if we can make them a couple of feet deep and really lay back those side slopes to where they're more of a natural channel that provides a secondary overflow path, we'd like to do that. Again, it's trying to put those properties back to a more livable state. So that's something that we're working on, is maintaining a secondary overflow path. Other things that we have to do, we talked about at our last meeting, is there's a cost benefit ratio that has to be achieved through all of this. And that's it's part of our federal funding requirement. So we work on making sure that we get that cost benefit ratio. And then Corey will talk a little bit about the no adverse impacts modeling. So that essentially what that means is, by virtue of the improvements that we're putting in place, that we're not diverting water anywhere where it hasn't gone before. We're not making it deeper. We're not making it faster. We're not sending it to anywhere that it went before. So we have an overall positive impact everywhere throughout the corridor. Okay, so a little bit more about the North Copeland Corridor. I think last time we talked, or when we met before, we actually had the inlet on the property line here. We can't get that inlet that far south. So this is, I don't think, is Don Stevenson? I don't see Don here. This is Don's property. So the inlet has actually moved a little bit to the north, and the pipeline alignment is on the south side of that property here. So again, this green is our pipeline alignment. Very difficult to follow property lines up here, as you can imagine. And so with the storm drains, with the hydraulics of the storm drain, every time we put bends in the pipe, it causes problems, right? It causes hydraulic losses in the pipe. So we have to try to accommodate that for that, and we really try to minimize that. So we're trying to minimize the bends in the pipe, but you can generally see the alignment of the pipe going all the way down to the Copeland basins. And then this in the purple is that existing channel that's there today, that again, we'd like to make some improvements to that channel as a secondary overflow channel, and make it more, I guess, more livable for the properties.
I'd call it a swale.
Yeah.
You say more like a swale.
Okay, so a little bit about the storm drain itself. This is our storm drain model. This is the 6-foot diameter pipe. The little boxes you see along there are bends in the pipe, or manholes. The storm drain will have manholes at least every 500 feet. So those will be points of access there. And just like a sewer manhole, you see it'll be very similar to that, and those will be flush with the ground. The green line is generally the ground surface. We're going to want, 3-4 feet of cover at least over the storm drain pipe, deeper in areas where we have those utilities and we're trying to miss them. But we got a lot of slope on the pipe, which is good. So the trick for us becomes getting the water into the pipe and being able to build enough headwater above that pipe to push the water in the pipe, push it all the way down through. So you'll notice here at the inlet, the water building towards the top, and that the blue is actually the water surface elevation. You'll see how it builds at the top. When the blue goes above the pipe, we actually start to get pressure flow in the pipe. So it becomes a pressurized system. So we get a pressurized system towards the top of the pipe, but the rest of the pipeline actually acts as an open channel flow. It's not pressurized, okay? More than you ever wanted to know about storm drain hydraulics, right? So here's our South Copeland alignment. So here's the inlet coming out of the forest. This is where the water comes in now. You can kind of see from the aerial imagery, but this is where the water comes in now. One of the concerns here was trying to get that inlet as far north as we could get it. There's another tributary that comes in there. So we've got that about as far north as we can get it. But again, you can see where that secondary overflow channel is, and that's the existing channel. So again, we're coming down the property lines. We're trying to minimize our bends as best as we can, following the property lines. And then there's places here where, for example, here, we're kind of cutting through the middle of the property because that's just the way the property lines are. But ultimately, we're coming down to the Copeland basins. So here's the Glodia pipe and the Glodia inlet, that 200 CFS that I mentioned about, and the inlet here. This is the south side of Copeland. The storage units are down over here, but these people are pretty heavily impacted by the flooding there as well. Last time we met, we talked about, hey, is there anything that we can do through this process of trying to help that situation? And so what we came up with was a 6-foot diameter storm drain pipe. Even though this is uphill, we are bucking grade to get down to that 10-foot diameter pipe, but we can make it work. So again, this is our 10-foot diameter pipe. You see there's a bunch of bends there. If you saw it kind of looked like a radius in the pipe. And so what you'll notice again, when I run the simulation, you'll notice the headwater that we need to get that in the pipe. You'll see pressure flow in the first part of that pipe, and we come really close to pressure flow where we have these bends. Right? And hey, Nick, just on the simulation, the hydrograph, how long does the flow occur? Do you remember? No, just the entire hydrograph where we get the flow. It's pretty quick. Yeah, so this is occurring over a period of like 15, 20 minutes on that peak flow. So it all happens pretty quickly, right?
What does that mean when you say the pressure flow and that where it was turning? What do you mean by it's getting pretty high in pressure flow? What does that impact?
It means that we have to be really careful how we build that pipe. Especially around that bend. And what we've done in the past is, where we backfill that trench, we've actually used concrete or slurry to make sure that thing's not going to move side to side or up or down. Because basically, it's like a water line at your house. You turn the faucet on and the water system's under pressure. And that can happen by virtue of gravity or a pumping system. But we're essentially using gravity, and then where we have those bends, we start to have hydraulic losses through the pipeline. Because we have hydraulic losses, the hydraulic grade, the water surface starts to get higher and higher, which can then result in a pressurized pipe. So if you have, for example, a manhole there and a pressurized pipe, you're going to see a fountain, right? So yeah, did I answer your question? Okay.
Bolting them all down.
Yeah,
But
we'll,
because frankly, we had some people think that they were fun to look at, take off and look. which
we've
is
had
not.
people pull manhole covers off while the pipe was flowing, which is extremely dangerous because that water's moving at 30 to 40 feet per second through that pipe, and if you fell in there, you're done. Yeah. Here, wait a minute.
Pressure in a storm drain pipe, if it's pressure flow at all, which only are in a couple of isolated spots here, is very low. When you turn on your faucet at home, you've got 40 psi about. This may be 1 or 2 or 3. So you're not going to see these geysers, okay?
Okay. Okay. So this is the this is the challenging one, and not only is it challenging from a design standpoint, but it's challenging to try to explain. But I want to try to explain it. So this is the Glodia, that 6-foot diameter Glodia pipe with the inlet being over here. You can see I said we're bucking grade. The road's going uphill, the pipe's going downhill. I need to get to go downhill to tie into that. It becomes a very interesting exercise in this because of the pressure that's occurring in the hydraulic grade line, I should say, that's occurring in the 10-foot diameter pipe can actually back water out of this inlet. It'll be under and that's what we're seeing, but we know how to fix it. We just haven't fixed it yet. So you'll see, what happens there at the inlet. And you saw that hydraulic grade line jump up there. So we're dealing right now with a little bit of a surcharge that's occurring, So even if we had no flow coming from the Glodia watershed and we had that peak flow coming from the Copeland watershed, it could push water back through this pipe, okay? So we're working on that, and we have a pretty good solution for that. But it's not shown on the plans yet, but we got it. Okay. If there's any questions about the storm drain, general questions, if there's specific questions, yes, sir? The expected lifetime of the pipe is at least 50 years. So I will be long gone. I think we'll mostly be long gone. Yeah. At least 50 years, but it's lasted longer than that. And I don't know if you want to mention anything about the pipe or.
Yeah, I can do that. So this pipe can be manufactured in Phoenix or it can be manufactured in Albuquerque. Tiffany has worked out an arrangement with the pipe manufacturer. The company's name is Contec, that they're actually going to establish a mobile mill here to manufacture the pipe here. Because one of the big vulnerabilities is it'll save us some money, not a huge amount, but some, because we're not having to pay for all that transportation. Think about these very large pipes. You get maybe 1, maybe 2 mic right on a truck. You're not, it's a lot of trucking. So, but the real benefit is that we're going to have a lot more control over the manufacturing and the timing, and not getting into dynamics. If you're aware, there's a lot of construction going on 17 right now with the Black Canyon Gray. So when we looked at the whole dynamic, even though we're not saving a whole lot of money, frankly, we got to have a lot more control over the delivery, and keeping that going is going to be really important to staying on schedule. So that gives them a lot more control. And if there is a problem, we're going to know right away, because Mike will be sitting on them every day. So So we'll know if there's any kind of issue, if we do need to truck pipe from somewhere else, if there ends up being an issue or something. But they've used these mills in many, many locations. This is not a new strategy or anything. They do this quite a bit. So, yeah, Ruthie, do you have a question?
Me. I'd just like
Oh,
to
sorry.
know where they're going to set this up.
We're working with the city of Flagstaff now to actually set it up at the landfill. So it'll be kind of out of sight, out of mind, and out of hearing, because it's not a huge operation, but there's a lot of a fair amount of activity and so forth. So it's best if it's not. Hopefully it'll all go through. We're going to the board for approval for the IGA, the intergovernmental agreement with the city on the 21st, and the city will be hearing it that evening as well. So right now we're not hearing any issues. The city's being really supportive of this, so we're fortunate. Got a good relationship there, so I'm pretty confident that's going to get approved.
Other thing that I should mention, so this is a metal pipe. It won't be a plastic pipe. We don't want to use plastic pipe because it can burn, right? If we get another fire, we could lose the pipe. So it'll be a metal pipe. So they'll actually be spinning this pipe up here. I don't think it's ever been done in northern Arizona, the mobile mill.
We never had this amount
Right.
of
This will be
pipe that would
this will be a
justify
first. But
no.
the other thing is, it's, as you can imagine, if you're taking, sheets of steel and you're spinning it into a pipe, it's kind of noisy. So we didn't want to put it right behind your houses. Right? Yeah, ma'am.
Were there any 10-foot pipes used at Brandis or Wapaki Trails?
No, that Wapaki Trails was a 6-foot diameter pipe, was not a 10-foot, and there's no pipe on Brandis.
And there's 2 pipe systems in Paintbrush that were constructed in 15, and they both worked exceptionally well all through the flooding last year. We didn't have any issues with sediment or debris, even though we had a lot of sediment and debris. And what were those? Were they 5 or 6?
The ones on Paintbrush are both 5-foot diameter, and it's the same type of pipe. It's called an ultraflow pipe. It's a very smooth bored pipe. It doesn't have the big corrugations like you typically see. It's much smoother, which is good and bad because we can move more water through it more quickly because we have less friction losses. But it's also more susceptible to, because it's moving so fast, to scour and things like that. But it is the same pipe that we just put in at Wapaki, and we've never had any problems with the ones over on Paintbrush, with debris and sediment. The one that just went in Wapaki, and the storm came right after that, there was quite a bit of sediment in that water because literally the work just got done on forest and it was bare earth, and also a lot of that sediment, before the vegetation, and there was no sediment in that pipe after that flow was gone. It moved through the system, so that was good.
In the bigger urbanized areas, these are very common. This is not an uncommon thing. It's pretty common that there's underground stormwater systems.
I know you have to get rid of some dirt. We have a very large field with nothing on it, and so if you want to get rid of dirt cheaply, let us know if you have the capability of putting on us, and the engineering works. So I guess Tiffany needs to know that too.
Yeah, well, thank you for that, and thank you for bringing that up because I mentioned the work on the secondary channel, right? The easement is for the storm drain pipe. We're not looking for an easement to do the work on the channel, but we're going to have some mechanism to get onto property and do that work, whether it's a temporary construction easement or whatever it's going to be. There'll need to be some mechanism to get onto people's properties and do that work, but it won't be part of that permanent drainage easement that's associated with the storm drain pipe. So thank you for bringing that up.
Yeah.
Yes, sir?
Can you talk about the Gallodia pickup at all?
Sure.
Yeah, just how you plan on just handling that, how much of the area is going to be affected, and also any time frame, as far as I'm sure that's the lowest on the priority list.
No, it's not the lowest on the priority list.
Okay.
It'll occur. So this will be constructed as part of these corridor improvements. It'll be constructed at the same time. It's not going to come at a later date. We are getting an easement from this property owner to go ahead and build that inlet. And basically, and this is on the plans back there, and we can look at the plans. But basically where that channel comes through the property, we're going to kind of regrade that channel to direct the flow into the storm drain pipe and not into those 6-foot diameter pipes. So the water's going to go there. If we get enough water, where the water surface, where the head on that pipe gets so high, it will spill over and it will start delivering water to those 6-foot diameter pipe, or I'm sorry, those I think they're 36 or 30s. Yeah. So they're not going to see water until we get more than 200 CFS going, coming out of that Glodia watershed. So it will significantly, and Corey can show this as part of his no adverse impacts modeling, but you'll see, this area south of Copeland gets dried up quite a bit. Yes, ma'am?
Impact the trail access there.
There'll be no impact to the trail access. The trail access is right along that property
Right.
line. Yeah, there'll be no impact to it.
Really?
Nope.
It looks like you're gonna go right through there.
It'll be underground. The pipe will be underground. And so the actual trail itself is like right.
Yeah,
Here,
yeah, it's right
yeah.
there.
Have it likely be in the right of way, right? We may have to do some
We
jogging down.
can't quite get the head wall in the right of way, which is why we needed an
The
easement.
pipe itself.
Oh, the
but
pipe
going
itself,
down the
yes. The pipe
booklet,
itself will be
It
going.
may have to turn a little bit
So,
there.
but the trail access will be blocked while you're doing construction, I would imagine.
It would be temporarily closed while they're
Right.
building in this area. Yes.
Okay.
And that keep in mind that even though this is a 6-foot diameter pipe, this is probably, I think this is the deepest section of pipe where we are absolutely maxing out the capability of our shoring in that area. If we go any deeper than that, we have to get into a whole different dynamic of a different structural type of shoring, which, we really want to avoid. It just adds more cost. Yes, sir?
Us to mitigate what has happened downstream of the 6 culverts there off the Glodia drainage. So what has occurred is I still have that 6-foot trench by 6 wide. Can I do anything? Is this going to allow me to do something? It then affects Mike Anderson, who's sitting in front of me, and then continues on down. So
Yeah, and I think, keep in mind that we're talking about that 2 inches in 45-minute event, and that larger storm events can occur. And if they do occur, you're still going to see water here.
See water.
correct.
Okay.
Right.
So, one thing that we can do, or one thing that we talked about, are the integrated mitigation areas. And maybe this is a good candidate for an integrated mitigation.
That's part of what will be evaluated.
Yeah.
I mean, I'll be honest, the limitations of the funding, we're going to be very limited in what we can do. The properties that will be really targeted for that, frankly, will probably be at the very top of, against the forest. They are probably going to see the most potential for continuing risk, right? Obviously, because that's the headwater. But we'll do the best we can, but we can also advise you, if you want to try to do more, to add more mitigation, to, more, I'll say midterm or longer term mitigation to your property, we can advise you in that direction. But we're going to be pretty low. We're going to be down to pennies here. This is going to exhaust every dollar we have right now. So,
Well, just what can I do? All I wanted to do is a plan, because this came up during the Schultz fire. I had people come out to my property because it wasn't flowing north of Copeland at that time. It came right through my property. I was given a option to take out a low interest loan to allow they would come through and mitigate. Well, then they said that it was still my responsibility that if it affected anybody downstream, that whatever was done on my
Right.
property, I'm still held responsible. So it.
And
then
that would
did
be true whether, because we would do those type, if we do identify that, there would be some benefit to some additional mitigation on an individual property or a set of properties, really, it's an integrated system. If we did identify that that's needed, I mean, we would provide an engineered plan for that. But again, it's going to have to demonstrate that there's a real problem. And we would work with you on that, So,
Well-
but it will be done under what's called a cooperator agreement. It will not be a draining, we don't have the capacity to continue to manage that. We're going to be maintaining
Well,
that rest of that entire system, that type of system. And we did several of these up in Wupaki because we did have properties that we weren't able to get to the 25-year. And so there were issues that we still had remaining. And Rick worked on those plans, but it's going to be very limited in this court. One, you're going to see good results on the modeling, so the need is less. And there's only just so much we can do, right, with the cost benefit and everything. So, but certainly if you want to try to effectuate more, we can try to help work with you on that. So, yes.
So just to clarify, you would provide the modeling and we would provide the implementation of the modeling?
Well, but I don't want to commit to anything until we actually see what's going on your property, okay? I don't, yeah, you're going to see it here. in a
I
minute.
see though, because it has changed throughout, obviously. I mean, this is the
Yeah,
plan.
you're gonna
Like
see
you
it.
said, though, we're
Yeah.
already we're already exceeding the 2 inches of rain in 45 minutes. You just said that earlier, correct? You said that.
No,
the-
we
the-
never even remotely had a 2-inch storm last year, just so you
I thought,
know.
okay, maybe I
50
misunderstood. I thought somebody said that
It was 10-year.
the model was 2 inches and it's already exceeding that.
Yeah, the most you've seen on the Copeland in the past 2 seasons is about 1.5 inches
Okay.
in 45 minutes. And that happened one time, and all the other events were 1 inch or less.
I just, to do something with the property, because I have 2.5 acres that is unusable and a road access of the property is inaccessible. And
Yeah,
I shouldn't say
we could-
anything because Mike is the one who.
I mean,
catches
we
the
will
water
sit
after
down
that.
with anybody, that's kind of Rick's role in all this is if you want to look more specifically at your property, if there's more that you want to do. But we're exhausting all of our resources to get to the 25-year with the big system,
Sure.
right? But if you want to do more, we'll share that information with you. And depending upon what you want to do, will it hit the threshold that you got to have a grading permit or not? Then you do need to get an engineer. So we'll look at it. It just depends on what that risk level is. But we don't have any money set aside for that. So yeah, we're going to be very limited in what we can do because we're trying to effectuate the big system to really alleviate the big pain, right?
Yeah, and so here's Glodia also, and so this, for any of the events that we've seen so far, this is where it all would make it into the pipe, and this is what it would look like downstream. So these flow depths coming down would look for all the events that you've had to date since the pipeline fire. This is what it would look like.
Dating back to the Schultz, where it's again over 6 foot deep behind a track and sitting in like you had a human standing by the walls. I had that same effect on my property, and I have it all documented. And every time it runs, comes across there. And again, fortunately, I have nothing built out there. It is avoiding my home. It's leaving me alone. It blew out a fence that I just completed, but it goes to Mike here, right? And so now my arms are tied, my hands are tied, and I wouldn't want to do anything to affect him.
Yeah,
And
right.
then it
No,
just continues. But-
Appreciate that you're.
Well, I mean,
yeah,
it's a neighbor. We have a
people
good
aren't
community,
sensitive.
but I can't do anything there. And again, I'd like to do something to the 2.5. In fact, I have more dirt out there than you probably have in your ditch. I've been stockpiling it twice now.
Yeah, I've seen.
Yeah, I
yeah.
get the guys up immediately because I know the cost of diesel and carrying it to the dump. So
Yeah.
I've stockpiled it. So I'm willing to do
Well,
whatever.
we'll look at it
Okay.
with you. We'll look at it with you, but I think you're going to see quite a bit of benefit from this.
Yeah. So I'm Corey Helton. I'm with J.E. Fuller. I've been involved with the modeling ever since the Schultz. I was involved with that. I've been involved with the rain gauges that you looked at. I've helped install those and maintain those, and pretty familiar with all the precipitations that the rain gauges that you've seen up there. So that's kind of my role within the modeling. And then as far as the NAI goes, it's the same NAI that's been in place since the Schultz, and so it's not always easy to meet the NAI. It's difficult to implement mitigation sometimes and not have any adverse impact anywhere. And so what we'll be looking at is, it doesn't mean there's no development, but what we do put in place, we don't want to be affecting people downstream or upstream of the improvements. And that we have been doing since the Schultz, looking at that, and this is what it entails. And this has been in place since the Schultz, and we've been able to meet it in all the improvements that we've made so far. The 1-inch event, with the current NOAA statistics, would be 50% chance of happening in any given year for the 1-inch event. And for that event, we don't want to increase the water depth by more than 1/10 of a foot on your parcels. For the 2-inch event, that's a 4% chance of happening. We probably see that on the Copeland. It's happened a couple times since the Schultz fire. So it's above 4%. I would say it's about, with the past 10, 12 years, it's probably more on the order of a 20% chance of happening in any given year. And for that, we would not want to see an increase in depth more than 1/2 a foot on any of your parcels. The 3-inch event it hasn't happened on the Copeland Basin since the Schultz. And for that event, we wouldn't want to see an increase of more than 1 foot. For all 3 events, we want to look at the velocity. We don't want to increase the velocity. If it's greater than 3 feet per second, we want to be looking at that, because at that point, we can start having erosion. We can start moving stuff downstream. So if it's greater than 3 feet per second, we start watching it, and we don't want to increase that by more than 10% or by more than 1 foot per second. And so that's the criteria that we're sticking to, and we're meeting that still, again, with this one, with the 60% plans that we're looking at. So for a 1-inch in 45 minutes, this is kind of the flows that you would expect. As Chris was pointing out, without the measures.
This is from the LIDAR.
Yeah.
That was done last November.
And that might be worth pointing out. So we have a few snapshots since we've been involved in that. We've been modeling since the Schultz. Then we took another snapshot in 2016. So the watershed up to 2016 hadn't fully recovered, but you're seeing an 11 times increase in discharge even from the 2016 period. So for every 100 CFS that you might expect, you would expect over 1,000 CFS coming through your neighborhood. That's the kind of increase that you would be seeing. And then we took another snapshot even after the pipeline fire, and that was in November of 2022, because you've had some flows and you had incised channels, and that was changing flow paths as well. So what we're looking at right here is based off of the November 2022 snapshot of how flows would come through your neighborhood. So we take that snapshot, and then I take the designs from Natural Channel and Civil Tech and implement that model into our models and try to identify where the adverse impacts might occur. Things look really great for the 1-inch event, and this was what I was showing earlier. All the way up to the 2-inch, you pretty much you dry it out. So 1.5 inches is the most you had. All of that would make it into the pipe system and the designs that have been presented so far. And so this is what it would look like. You would, at Glodia, it would go into the pipe system. It would come all the way down. You can see in here we have a lot more darker colors on these western basins. So we've expanded that and deepened those. And that's why it's so much deeper through here. And then this is pretty similar as to what it was prior, because these do not have any modifications within the model. So I'll go on to the 2-inch event, and that's our target. We're trying to target for our designs for the 2-inch event. Oh, sorry. This is our NAI. So this takes the difference. So the yellows would be 1/10 of a foot, and up to 1/2 a foot. The oranges would be 1/2 a foot to a foot, and the reds would be anything greater than a foot. So you can see where the fans are. We're spreading it out, so we're making it deeper out here. We're getting all the flows into a pipe, so it's deepening back up when it comes into the pipe. And then also here, you can see the flows increasing coming over here, and then we're picking them up on the North Copeland right here. So that's where you see the increases, and you don't see any more increases until you get down to the Copeland basins. 2-inch event, you start seeing more alluvial fans, the flows spreading out like you've seen. The incised the canyon through here as it's coming through here, so that those are deeper than you would have seen initially after the pipeline fire. But as it incised, this is what the November 22 condition would look like. And still, it would still have the capability of spreading out on the alluvial fan and making its deposits in other locations. So next I'll show what it looks like with the pipes. So here's Glodia. So if it actually reaches the 2-inch event, you would start seeing some flows coming down on the pipes and coming down through here. There's going to be some further modifications in here, so this would actually be even less than it is currently right now. You'll probably see some of these flows coming from the Peaceful area coming this direction. This is more like a 30% plan up in here, so we're still getting some flows coming through here and making some further modifications, and this will likely disappear as well. But here is the North Copeland, where the 6-foot pipe is, and you can see it's picking up the full 2-inch event right here, and that will be what will take place on the South Copeland as well.
So you can see that basically, like back to your property there, you're looking at in the 2-inch storm, what is that, 1/2 a foot to a foot, right?
Right in here, yes.
Is it 1/2 a foot to a foot?
Yep.
If you did nothing more than just open channel along where there is an easement either side of Copeland, you could then take it and run it right down there to the drainage and avoid going through personal property, just run it along the roadway. I know that's going to cost money, but that's something I wondered all from the get-go. There is an easement there along the road, even if it's open like it is on Campbell, and just divert water onto that. And again, not understanding how it would get across over to the sediment ponds again, but there's an existing easement along Copeland.
Chris, there's not the.
Well, I just meant that I know that my
volume of
property.
water is pretty limited in this 2-inch model.
Pardon, I'm sorry?
The water that's not going into the storm drain is pretty limited
Okay.
now. So, again,
But-
when you start looking at,
But if your house was down there, what is minimally limited to? I mean, if you lived right there, and like I said, my house isn't there, but what is an acceptable water flow for you?
well, there's, I don't think we see any flows actually affecting the homes.
Well,
So-
I do, because I see the neighbor that it runs through his place.
I mean, most of that's pretty minimal flow.
But that's why I meant, so if it's minimal, so even if, I mean, I would give
You
you
know, I
access.
wish we could dry everything out
Oh, I understand.
I
I'm,
wish
mine-
we could. I mean,
correct,
in
but there's not a
perfect
plan
world-
though. Everywhere else there's a
Yeah.
plan, and
No.
there is a roadway with a easement on it or a means to put
I
something
understand what you're
right along the
saying.
road.
I understand what you're saying, but we have a level of resources to meet the 25-year. This is what's meeting the 25-year, you know?
Asking a future, because I was told back during the Schultz fire, because my property was affected more so than the stuff on the north, that something was gonna be done back then, that's all. And nothing was
No,
addressed.
yeah, because we never got any of the easements to move forward with anything in
Well,
this corridor.
I didn't know what easements you needed to go along Copeland, because there was an easement already.
And there was a lot of flow to the north of you. So, yeah, the
Yeah.
main flow was actually still to the north. But anyway, more discussion
Yeah,
can happen
that's-
afterward.
And-
You know, we're going to do the best we can.
So it might be helpful to also mention, so you have over 200 coming in through here. You have less than 50 making it past here. So you're picking up more than 3/4 of it. And I suspect that'll even increase some more with the modifications that will be implemented here, allowing some more of these flows to get this direction. The 3-inch, I did it again. But so this is where we're looking at the oranges and the reds. So oranges half a foot to a foot, and the reds over a foot. And so you can see again in the fans, and then nothing through the neighborhoods until you get down to the Copeland Basin. And that's where you're seeing your increases in depths and velocities. The 3-inch, again, you haven't seen that, and it's a lot of flow. We're at coming down this area, 3,000 CFS, and so we're not going to capture all of that within the mitigations that we're proposing. But we still want to look at it to make sure that we're not adversely impacting any neighborhoods using the NAI criteria we've been using. And so once the mitigation measures are in place, this is what it looks like. It's still significant. You still have a lot of flows.
This is a 100-year rainfall event, 1% chance, right, probability.
These models to then hold the same thing for rapid snowmelt because of the snowpack we had last year. Remember when we had the rain and everything melted and then we had the flood and flag? Same kind of a thing. So if you have a rapid temperature change with the snowpack and comes down, so it would typically take the same flow, would you imagine?
It's going to take the same level of CFS irrespective of the cause, right?
From the water, where the water's coming from as well, because you've got the whole range. When we had the huge snowpack this winter,
Right,
it went,
right.
at one time I know that there was a
They're
concern.
modeling that the rainfall is 3 inches over the entire watershed, including all the way through the neighborhood. So it's a pretty worst case, right? I think that's really only happened one time, July 20th, 2010, when it rained over the entire watershed at one time. You know, you watch the gauges, you all watch the gauge, you see how the storms migrate, right, back and forth, or they go north and don't come back, or sometimes they go south and don't come back, and you know, so it can happen. And yeah, we always talk about how, you know, that's why we tell people don't take down your mitigation after the monsoon, because we can have rain on snow events. We can, they're real.
And we've looked at that as well. And these sort of scenarios are on a worst case scenario where we're at. You get more volume with the rain on snow events, but you don't have as big of a peak discharge.
I was wondering what effect,
Yeah,
rain
and
came on the snow.
we looked at that with the National Weather Service this past spring because we had a lot of snow this past year.
Correct.
And so that's one of the things we were looking at.
Although it was interesting in this area, there were a lot of other areas across the county not burned that had a lot more flow than this area did, interestingly. So,
But and those were pooled areas usually where you can
Right,
the volume
right.
the volume becomes more of an issue. So the volume, like once you got down to the Copeland Basin area, that becomes a volume issue. But through here, this is a peak flow sort of issue. And so this is what it looks like with your non-adverse impact analysis. So the red is the areas that we'd be concerned about. Again, at the fan areas, the Copeland basins, but this is where we start picking up a little bit through here. So the swale, where the swale is, and trying to smooth out the surface on either side of that and keeping the flows within the swale. This is where you have some isolated areas, but they're still within the NAI criteria. But this does affect some parcels down here because you get closer to the Copeland Basin.
Yeah, and just one thing with that, keep in mind too, that we're taking those deeply incised channels and we're filling them. We're filling them with dirt. Opposite.
Okay.
So that comes into play as well.
And that's what I got.
Any questions for Corey? We ran the modeling on Wupaki, I think, at least 15 times. It was really, really challenging. And these divided flows are pretty challenging. Fortunately, everybody kind of took that. Chris and Alan and everybody did a good job of taking what we kind of learned off of that dynamic and applying it here. And we were able to get to a really good modeling fairly quickly this time, fortunately. Right. I don't know. I'm mic'd up. All right, no other questions? So, I mean, we're really thrilled with this. This is a great result. Like I said, in Wupaki, we never got to the 25 because there were just too many conflicting factors. And in the end, we said, hey, we're going to do the best we can, and people were really great there. And fortunately, it still worked really well on that big event. So next steps, reiterate again, got to get the drainage easement. See Shanique and Nikki in the back, and if most of you know if we need an easement from you, because Chris has probably already talked to you. And as soon as we get those easements, we want to move forward with the utility relocation and start whatever level of construction we can, whatever the weather will permit. And Mike's pretty committed to trying to work as much as possible through winter. So it's going to have to get pretty bad. He's going to try to do as much as he can. Complete the designs. Obviously, we're at 60%. We've got to get to 90s and 100. The plans are out for review now by the NRCS and district engineer. And we have to get approvals, of course, for those. We have to get approval for the construction cost through the board of directors for the flood control district. And that's part of the process we go through with Tiffany through the CMAR process. So again, all that just comes as soon as we get the drainage easements. I think we've covered a lot of this. And this is all along. We have a set amount of money. We can't use any of the money to secure the land rights. And I want to reiterate a number of the points that Chris made about what's ineligible. We can't replace landscaping. we're gonna manage your fences. Frankly, they'll probably, if it's like a 3-strand or 4-strand, they'll pull the pipes, whatever you have, if you have pipes, if you have fence posts, whatever, they'll roll it up and they'll reinstall it as much as they can, because that is not a cost that we get reimbursed for. And, you know, in some cases, we know we've got some challenges on a few properties and we'll have to work through that. So those are some limitations we have. As we've mentioned, and as Nikki and Shanique work with you, they're gonna provide you with the documentation that you can take to your tax preparer to potentially be eligible for a tax deduction, because your donation of that easement is considered a donation to the government, like a donation to a nonprofit or government, and that's typically tax deductible. I'm not a tax advisor. You'll have to, everybody's taxes are different, right? So you'll have to pursue that yourself, but you'll have the documentation to take to them to do that. So again, if you have any questions about what's proposed on the property we shared tonight, some areas he will have to do that additional shoring. They will have to be wider easements. We're going to the 30-foot to accommodate that. But so if you have questions, make sure you get with Chris or Nick or Rick in the back and talk through with them. Because again, the sooner we get those easements, the sooner we'll be on the ground. And so I think move forward. Obviously, we want to move as quickly as we can because we can't dictate the weather over the winter. And we're in El Nino. The latest I've seen is that the percentage of likelihood greater than normal rainfall is going up. It was about 10%. Now it's more like 30. So again, just relative to the fences and stuff, we're going to do the best we can, to manage that impact. And we just got to keep working together, folks, to get this done. And we're pushing really hard. So appreciate everybody's willingness. Again, if you have any questions, get with us tonight. Yes, sir. Tomorrow. I mean, the sooner I can green light him to start, the more apt that it will happen before monsoon. Very, very limited.
Okay.
And most of the concerns are around trees and, that type of thing. And I understand, a lot of people lost a lot of trees in the fire. But I'll tell you, one of the other things we're really looking at moving forward with for this county is what's called a community wildfire defense effort. And take advantage of this opportunity to reduce the number of trees on your property. I hate to say this, but it's going to burn again, folks. It's not if, it's when. And so we're trying to think that way. We didn't think this, I'll be honest, we did not think this way last time. We did not. We thought, oh, this will never happen again, and da-da-da-da-da. Right? Well, so much for that. We are in a different world today. I just spent the last year plus serving on a federal wildland fire commission that was set up by Congress, and, we are in a whole different world of wildfire dynamics now. And what we're seeing in a lot of places now, yeah, your area's now burned. The threat may well come from the neighborhood more now than it does actually from the forest. So, think about, well, what do you really want on your property in terms of trees? And I know we love our trees. My neighborhood's horrible. I live in town and it's horrible. And it's, if there's fire comes up that hill, the houses, they're gonna all be gone. You can't see a rooftop. So, think about that as you go through this. As much as we wanna hold on to every tree, think about that. Defensible space, it does matter. And I know we saw some variation out there under pipeline with the 70+ mile-an-hour winds, but in a lot of places it did have a positive impact. So, all right, any other general questions before we break? And you can go back to the back and look at plans. And anybody else have any general questions? All right, thanks again for hanging in there with us. We'll get there, we're working through every issue that comes up, so hang in there, and email us if you have questions, get a hold of us. So sign your easements. Thank you.